Today we're going to learn 4.6. This is the product rule. So we're going to find the derivative of two things being multiplied together. So far we have learned the elementary rule of differentiation. This is elementary rule because it's the easiest. It's the one we use the most often. So let's explore now the product rule. So here is the rule. When finding the derivative of f of x times g of x, or when finding the derivative of one factor being multiplied by a second factor, this is the rule. We take the derivative of the first factor, f of x, multiply it by g of x, not the derivative of g of x, just this whole second factor. And we add that to the derivative of g of x multiplied by the factor f of x, not the derivative, just the factor. Another way to write this then is underneath here. When we find the derivative of f times g, that will equal the derivative of the first factor multiplied by the second factor plus the derivative of the second factor multiplied by the first factor. I have this memorized a tiny bit different way. When we're finding the derivative of two factors multiplied together, it's always the derivative of the first factor times g plus the first factor times the derivative of the second. So exactly the same formulas. This one just always keeps the first factor first, the second factor second, and then you take the derivative of the first in this term and the derivative of the second in this. Okay, let's practice this. I've realized on my previous videos, sometimes I write on the bottom of this smartboard screen where you cannot see. So I apologize for that. I hope you've been able to figure that out. I will now move my work to the top of the smartboard screen. So let's look at number 1. I've rewritten number 1 as h of x. We've used f of x in the product rule, so it's confusing when we use it to mean two different things. So let's call this function h of x. You can see h of x is the multiplying of 2x minus 5, the first term, multiplied by the second factor, 3x plus 1. And so then, when we find the derivative of h of x, it's going to equal the derivative of the first factor multiplied by the second factor plus the first factor multiplied by the derivative of the second, which in this case, derivative of the first, 2x to the power of 1 minus 1, which is 0. Derivative of constant would just be 0, multiplied by the whole second factor, plus the first factor, multiplied by the derivative of the second factor, which would be 3x to the 0. I won't write it this time. Okay, so let's pause this, and I'm going to multiply that and gather like terms. So the derivative of h of x using the product rule is 12x minus 13. That means that the slope of the tangent line to this function is 12x minus 3. Now, if I knew what x value we were finding the tangent line at, I could put that in and find the slope here. But here's the equation of the slope. Flip the page over. Okay, so we have got, again, two factors being multiplied together. This first factor we refer to as f, the second factor we refer to as g. So when we're taking the derivative then, we've got the derivative of y. We write it as y prime. The first factor derivative would be 6x multiplied by the second factor plus the whole first factor multiplied by the derivative of the second factor. Okay, we're going to multiply this out, collect like terms, and then give a simplified answer. And using the product rule, y prime is equal to 36x to the power of 5, subtract 60x to the power of 4. Okay, Number 3 is very, very similar. I'm going to leave you to pause and work through that on your own. Let's move then to number 4. Okay, number 4, you can see it's got 2 factors being multiplied together. We're just moving up in the difficulty level because we've got negative exponents, we've got fractions as exponents, etc. So we still have our first factor, we're calling that f, and our second factor, we're calling that g, and we're looking to find the derivative of f of x. So we've got the derivative here. We take the derivative then of f, we multiply it by g, we add that to all of f multiplied by the derivative of g. So let's go through this. I'm going to pause it and find the derivative of each of these. And yeah, you can do that, pause it, do it on your own, and we'll see if our answers match. Okay, did we get the same here? The derivative of f multiplied by g, just copied it from there, plus f, just copied it from here, multiplied by the derivative of g. Okay, now we're going to FOIL each of these and gather like terms. Remember that when we're multiplying same bases, we add exponents. Okay, in order to add fractions, they need to have common denominators. Good luck. Okay, after that work, here's the derivative that I came up with. Hopefully it matches yours. The only thing we could do here, if asked, and it's probably more the norm, although in this section we don't worry about it too much, is to put our exponents in descending degrees. Okay, let's look at number 5. I'm not going to do all the work with you here, except the start here where we need to rewrite the original y with x2 powers instead of using radical signs. So here we've got 4x to the half plus, here we've got an x in the denominator. We'll move that to the numerator and make the exponent negative. Here we've got a cube root, which we know is the same exponent as 1/3. Subtract x to the 3rd. Okay, then just like our previous questions, we've got f here and we've got g. And you will find then the y prime, or the derivative of y, by using the product rule. The derivative of f multiplied by g plus all of f multiplied by the derivative of g. And when you follow that all the way down, you should arrive with the answer of y prime is equal to x to the power of -1/6 minus 2x. Okay, moving on. Okay, number 6 here, it's on my page 2. We're asked to determine the derivative of function f at x equals -1 if this function f of x, as you see there, equals that. And then not only do we want to, are we asked to find the slope here where x equals -1, we're also asked to find the equation of that tangent line. Okay, so the product rule is made for 2 products being multiplied together. Here in f of x, we're given 3 terms multiplied together. And so you can see if I would multiply or distribute x cubed, I would get the following f of x. It's interesting to note that if I would multiply this all through and find that f of x, I can take the derivative of that very easily, just using the elementary rule. I'm going to pause and show you that. Okay, on the right here you can see the purple. This is f of x2. This is these 2 factors all multiplied together. We get this. And then, using the elementary rule of differentiation, we can find the derivative of that very easily, and we get this answer. Let's find the derivative using the product rule of these 2 terms and see if we get the same answer. Okay, so we've got the derivative of f of x then is going to be equal to the derivative of the first term, what we call f, is 3x squared minus 8x cubed multiplied by g. Ooh, I better write small. Added together with the original f, our first term, multiplied by the derivative of the second term, g, which is simply 3. Okay, once we multiply that out, we will get 9x cubed minus, I'm going to pause and do this work, okay? Okay, here's these two FOILed together. We get that big long. We gather like terms, and we should, if you did it in your notebook already, get negative 30x to the 4, that's here and here, plus 20x cubed, that's here and here and here, grouped together, and then a minus 3x squared, which you'll see here, same. Yeah, I think this way is much easier. Of course, in this section, we're learning the product rule, so we've done it this way. There will come a time when we will need to use the product rule, and it's going to be easier. So this is just demonstration. Okay, so we've found the derivative now. Let's find here the derivative, this answer, at x equals negative 1. So we want to know the slope of the tangent line when x equals 1. So the slope at x equals negative 1 is f prime of negative 1. So let's put that in to our equation we found. 30 times negative 1 to the power of 4 plus 20 times negative 1 to the power of 3 minus 3 times negative 1 to the power of 2. That all, when you add that all together, should equal 53. Now we know that, negative 53. We can write that over 1 because this is the slope, right? This is the rise over the run, or the change in the y value, the change in the up and down, over the change in the x value, the across. Okay, we weren't just asked to find the slope at negative 1. We were asked to find the equation. So we know from that m equals, I'm not sure why there's an eraser. I'm just going to go with it to finish this up, and then we'll try to get rid of it later. M equals negative 53. X, we know that that equals, see, with this eraser, that happens, darn it. Okay, x equals negative 1. Y, in this case, when x is negative 1, we put it back into the original question. So we're going to have a negative 1 cubed. Okay, that is very frustrating, and I'm just going to write down what that equals because it keeps erasing. Y equals 12. The only other thing, y equals mx plus b, that we need is the b. And when we put, let's see, y equals m times x plus b, we solve for b here. B equals negative 41. So now that we know those things, we can write the equation y is equal to m times x plus b. Here's the equation. I'm going to show you this on Desmos really quickly so you can picture it. Okay, so here's the original function. The original function is in purple. And when we multiply this original function together, remember the leading coefficient or the leading term was negative 6x to the power of 5. So negative 6 makes sense. Our purple function is going down. X to the power of 5, remember it's odd, so it makes sense. You could easily draw this original function. Now, we're looking at x equals negative 1. Find that on the graph. Trace up. We're finding the equation of the line that is tangent to that spot. So you can see the blue equation, that's the one that we found in this last example. And you can see how the blue line is tangent to the purple at x equals negative 1. You can also see that that happens at y equals 12. That's exactly what we found as well. Okay, so your assignment here, back over to the Smart board, your assignment is 191 numbers 1 through 20. Good luck with that. Remember, again,